Welcome to one and all. Our project title is about composition of performance of given liquid rocket. We have done under project guidance under the Dr. Shankar and B. Our batch members are Nithin Dinesh, Kumar and Arun.
Welcome to all, and we are the students from Weltech University, and our project title is Composition of Performance of Given Liquid Rocket, and the project guide is Professor Dr. Shankar, and we are the batchmates with Dinesh Kumar R, Arun Kumar R, and Nithin R, Vinoth Kumar K. And this is abstract. Abstract is the finding the performance of liquid rocket by using a photon software for a 4 stages. And the performance analysis for a 4 stages of rocket was carried out using a in-house development code NASA SP273. And the 4 stages are, the stage 1 is kerosene and liquid oxygen, and stage 2 is liquid oxygen and liquid oxygen, and the third stage is liquid fluorine and liquid oxygen, and 4th stage is hydrogen and nitrogen teroxide. And this is the introduction and the principal operations. And these are features for a photon software. And this is the main parameters which are taken. And the main parameters are continuity, momentum, energy, and mass flow rate, and velocity of flow. And this is stage 1, and the properties of liquid rocket propellants. And these are the properties: compound, chemical formula, molecular weight, and density, melting point, and boiling point. And this is for the second stage properties, and this is third stage, and this is the fourth stage. And this is the picture clearly shows the combustion is taking place. And these are the advantages. And the advantages are higher pressure, lower turbine temperature, higher performance, and disadvantage moderate performance. And this is a thrust chamber. The thrust characteristics are combustion, high pressure, high temperature, very low net fluid velocity. And the exit characteristics are flow expand to fill enlarged volume, and reduce pressure, reduce temperature, very high fluid velocity. And these are the inputs we given for a first stage, and for values are given for a area ratio under rocket equilibrium and a rocket frozen. And these are the codes we taken to put in the software, and we get the outputs. And this is a chemical reaction for stage 1, kerosene and liquid, and the graph is plotted between the area ratio and molecular mole fraction. And this is the thrust coefficient for stage 1, and this graph is plotted between the area ratio and thrust coefficient, and C is denoted the convergent, and T is throat, and D is a divergent for first stage. And this is the input parameter for a second stage, and the values for area ratio, and the codes for a second stage of rocket. And this is a chemical reaction for second stage, hydrogen and liquid, and the graph is plotted between the area ratio and mole fraction as a first stage. And this is for a thrust chamber for a second stage, and the graph is plotted between the area ratio and thrust coefficient, and C is convergent, T is throat, and D is divergent. This is the input parameter for a third stage, and codes. And this is a graph for a third stage, chemical reaction for a third stage, and the graph is plotted between an area ratio and mole fraction. And this is a thrust coefficient for a third stage, and the graph is plotted between area ratio and thrust coefficient, and C is convergent, T is throat, and D is divergent. And this is the input parameter for a fourth stage, and this is the codes we are taken for a fourth stage. And this is a chemical reaction for a fourth stage. The graph is plotted between the area ratio and mole fraction. And this is the thrust coefficient for a fourth stage, and the graph is plotted between area ratio and thrust coefficient, and the C is convergent, T is divergent, and T is throat, and D is divergent. This is a equilibrium output for 4 stages, and this is plotted for a pressure, and the graph is plotted between the area ratio and pressure for 4 stages. This is a equilibrium output for a temperature, and the graph is plotted for 4 stages. And the graph is plotted between the area ratio and temperature. This is a frozen flow condition output, and the pressure. This is put for a pressure, and the graph is plotted between area ratio and pressure, and for 4 stages. This is a frozen output flow condition for a temperature, and the graph is plotted between area ratio and temperature for 4 stages. This is a reference we taken from the book and the guidance and our professor. Thank you.